Okay, so another application of integration is to find the area enclosed between two curves. We almost always need a graph, and it serves to identify which function has a greater value on the interval, and that function is going to be considered the upper function. The one with the lower value is considered the lower function. In each calculation we will use the difference of the upper and lower functions as a piece of the integrand, if not the entire integrand. So as we see, the area under the upper function is defined as, and I'm going to define this as f of x. We're going to define this one as g of x. So this would be the integral of f of x dx. This would be the integral of g of x dx, and we can find the area between them as the integral of, by subtracting them. However, because they are both in terms of x, we can write these as a single integral, and we can then say that area is going to be the integral of f of x minus g of x dx. And sometimes it'll help to do the algebra in between first. Okay, so let's look at example 5, and we're going to determine the area enclosed by the functions x and x squared. Now, we can see from here that the graph intersects at 0 and 1, so those are going to be our limits of integration. And we have simply then that area is going to equal from 0 to 1, and it's going to be x because that's my upper function. So this is f of x, and our lower function is g of x, x minus x squared dx. And so this is 1/2 x squared minus 1/3 x cubed, evaluated from 0 to 1. And so we have 1/2 minus 1/3 minus 0, and that gives us then an area of 1/6. Now, in example 6, we're going to see that the functions cross twice. And so therefore, we're going to need to use multiple integrals because the top function switches. So I'm going to define f of x is our f of x is equal to x, and our g of x is going to be our x cubed function. And we can see that our limits of integration are going to be from -1 to 0, and then 0 to +1. So we are going to start with -1 to 0, and we're going to subtract, instead of f of x minus g of x, we're going to say x cubed minus x, because x cubed is the upper function, plus then the integral from 0 to 1, and now x is our upper function, minus x cubed dx. And so we have 1/4 x to the 4th minus 1/2 x squared, evaluated from -1 to 0, plus we have 1/2 x squared minus 1/4 x to the 4th, evaluated from 0 to +1. Substituting in, we have 0 minus 0 minus, we plug in -1, and we have +1/4 minus 1/2, plus, now we're evaluating the up function first at 1, so 1/2 minus 1/4 minus 0. And so we have here 1/4 minus 1/2 is -1/4, multiplied by a -1. So we have 1/4, and then plus 1/4, and so our area is simply 1/2. Now, what if we don't actually have a graph? So you need to either sketch one or figure out what your upper values and lower values are. So we're going to start with, I know that I'm going to integrate from 0 to pi/4 because that's given. And so I need to pick a value between 0 and pi/4 to evaluate to determine which function is greater. So I know that pi/6 is between 0 and pi/4. So the sine of pi/6 is going to be 1/2. The cosine of pi over 6 I know is square root of 3 over 2. And so therefore I know that the cosine function is going to be the upper function. So we're going to subtract cosine x minus sine x. And then we're going to integrate. And so our area is going to be, the integral of cosine is sine x. Integral of negative sine x is positive cosine x. 0 to pi over 4. And so we have the sine of pi over 4 plus the cosine of pi over 4 minus, and be careful with, especially when cosine shows up, because the cosine of 0 is not 0. So we have sine of pi over 4 is square root of 2 over 2. Cosine of pi over 2 is square root of 2 over 2. So we have square root of 2 minus sine of 0 is 1. Cosine of 0 is 1. And so we have then our area is the square root of 2 minus 1. All right, and we will do example 9 in class. So let's look at example 8. And we have two functions and we don't have intersection points. So to start, we need to set these functions equal to each other. So we have x squared is equal to 2 minus x. And so we have x squared plus x minus 2 is equal to 0. And then we can factor this. And we have that this is going to be plus 2 and minus 1. And so we have x equals negative 2 and x equals 1 as our intersection points. So now we need to pick a function value in between those two and determine which function is our upper function. So I'm going to set this one to f of x and this to g of x. And 0 is between negative 2 and 1. So f of 0 is 0. G of 0 is 2, and therefore I know that g of x is the upper function. So we integrate from negative 2 to 1. G of x is 2 minus x squared dx. Negative 2 to 1, and this becomes just 2 minus x squared. And so our area is going to be 2x minus 1/2 x squared minus 1/3 x cubed, evaluated from negative 2 to 1. And so we have area is, we're going to evaluate this at 1. So we have 2 minus 1/2 minus 1/3 minus, evaluate this at negative 2. We have negative 4 minus 1/2 of 4, so 2. And then again, watch your signs here. Negative 2 cubed is negative 8. And so that's plus 8/3. And so our area is going to simplify down to 9/2. And we will talk about finding the area of a function between two functions using the calculator in class and the process